Okay, so our neural network is done training, and we can see in our logs that it learned correctly and it got that item in the test set correct. The actual classification for it was spam, and the output was also spam. So great. This is good. Now I'm just gonna get this out of here. I'm also gonna remove this. One of the things I want us to do is log the length of our data, so we are conscious of what's going on every time we run this neural network. We see the amount of length of data, especially when we dynamically change our ratio. So what we want to do is let's just log the entire data length first. Data.length, see what's in there. Then we are going to log our entire training length. Let's also see the amount we have in there. So training data.length, copy and paste this below. Let's see what's in there. Testing. I'm gonna log out. Oh, sorry, excuse me. I'm gonna comment out this part of the code and we test. Okay, so for the total of our data length, we have 5,566. Then in our training, we have 3,800 plus. In our testing, we have 1,600 plus. Cool. So now that we've done all this, what we want to do is take the entire testing data set and evaluate the model, okay? We want to get an accuracy score for this model we've trained, and also store the model for future use if it meets our accuracy target. For me, I think an accuracy of 80% or greater is good enough. So what I'm going to be doing is I'm going to be writing an evaluator function, if I can spell it right. So I'm just going to create that. I'm going to uncomment this. So the two things I want to pass into my evaluation is the neural network. So evaluator, I want to pass in this trained neural network. Then I want to also pass in the entire validation test set. So my evaluator is going to be looping through every test item to run its input and check its outputs and match it with our trained neural network's outputs and see if they match. If they match, we increase our score. Then when we are done looping through all these items in our test set, we get a score, then we calculate our accuracy. Okay, cool. So how are we gonna be doing this? It's pretty simple. So our neural network and our data are our two arguments. We are going to be getting the total of the entire data length, and let's create a score that starts at 0. Then we're going to be looping through every item in the validation data sets. Then we are going to say, give me the item at this index. We are going to be running the output of this item against the input. Essentially, what that means is the neural network output, we are going to be testing it on, and then they'll run this item, the input. Then let's log that. Let's see what it says. Neural network output. What does it say? Then also we are going to be checking the actual output to compare with what our neural network is telling us. So actual output is in the item, the output. Cool. What we can do is, as we know that it's either going to be a 1 or a 0, we can just say You know what? Let me transform both of this. Actually, I don't have to transform the item, the output. I only have to transform the neural network's output. So I want to remove all decimals and return that as a number, always 0 or 1. Okay, cool. So now I can say we can also say const output is equal to this whole thing, or actually let's say let's, excuse me, then we can say the output is actually this. We can say const to this output is equal to that, then get rid of this, then call this, and then we'll say if both outputs equal each other, then we can increment the score. So we're going to say if NN output is equal to the initial outputs in the test set, we are going to increment our score by 1. Then once that's done, let's close this loop so we can do other operations. Once we are done scoring, we can then calculate the accuracy for this entire test set. So we're going to say the accuracy is equal to the score divided by the total of items in our data sets multiplied by 100. I don't also want decimals, so I'm going to say to fixed 0. Let's log this accuracy. Let's log the total score first. So the total score, and let's also say what's in the total of the items we have. Total, let's see, let's just put a full stop there. And the total we have is total. Okay, then we can log our accuracy too. Accuracy. Then we can return all of this useful information, our score, total if we want to, then the accuracy. Okay, cool. So now that we know that we're going to be getting that from our evaluator function, we can then say that if we have a good accuracy, so if our accuracy, so let's just say accuracy threshold is 80%. So we can say if our accuracy is greater than or equal to the accuracy. We like this model and we would love to save it for future use. That is what we want to do. And the way we can do that is call our file system again and say, file system, I want you to write this file into our directory. I'm going to call it model.json for the file name. And the reason why I have this .json extension is because the neural network library allows us to export our neural network once it's done training into a JSON format, and we can also export it into a function. But as of today, as of this video, that is only available for a regular neural network and not a neural network GPU. I'm just going to do the JSON format only, and we also have to stringify this, that is converted into like a string, so that way it's easier to store. So I'm going to say neural network dot to JSON. Cool. So once we've done this, we are going to be getting a callback. just like we did. In this callback, all we get is an error. I'm gonna skip that. If we have an error, we can return. Well, let's see what's in the error first. If not, we can just say model saved successfully. Awesome. So now that we've done all this, I am going to run the training again and also run the evaluation on our entire testing data set, get the score, get the accuracy. If the accuracy is larger than our accuracy threshold, then we are going to be saving the model. If not, I will run this again. So this is going to take a while, so I'm just going to start it now and I will jump ahead to when it's done. Okay, looks like our neural network is done training, but then we have two errors. The first one is in our evaluator, we didn't say to fixed, we said fixed. So we want to say to fixed, and also when we are saving, we are checking for an error, but we didn't pass the error back in the callback function. Okay, so while I tried training the neural network, it was a bit slow. A neat trick I know is setting a flag called stack size and increasing that to your limit, essentially the limit of your operating system. But let me try and do this again. Before I run this, I want to show you how you can check it. So you can just say your limits -s, and mine is 8192. So I'm gonna set the stack size to 8000, and I'm going to try running the neural network again. Hopefully there are no more errors and we get a good accuracy, and we can save this model for future use. So let's run it now. It's gonna take a while, so I'm gonna pause the video again and come back when it's done. So our neural network is done training, but our accuracy score is 0. And the reason for this is in our evaluator, we did not select the first item in the output. If you remember, in the ultra output, the classification is in an array, so we want to select that first item. If we look around, we can see our neural network output is 1 and our actual output is 1, yeah, 0, 0. So, but I missed this one, okay? So our neural network is getting some right and some wrong. So we want to know the good accuracy score, and we are going to know that when we run this again. So I'm just going to do that right now. And I'll pause the video. Okay, so after tracking down those bugs or fixing them, our neural network has finished saving with an accuracy score of 90%, and we've been able to save our model. So let's look at what we have in our model. In our model, we have the type neural network, and we have an input feature dimension of 500, and the hidden layers optimized for this neural network is 250 hidden layers, and because we have a binary class, we have 1 here. So this is all that our neural network contains, and with this little piece of information that we've saved, we will be able to use our neural network in a Node.js server or on the browser or even in our mobile applications. In the next part, we are going to be using this saved model in Node.js, and we're going to be testing against some of the items in our validation set. See you then.